This is CPM Precalculus, Chapter 1, number 153. Use the triangle to the right to answer the following questions. What kind of special triangle is this? Okay, so we know it's a right triangle, right? It has the right symbol right there, so we know it's a right triangle. So triangle PQR is a right triangle, but that isn't special. Remember, special triangles are more than just like our types of triangle. Special right triangles, we have 30, 60, 90 or 45, 45, 90. So remember, what is the angle measurement of angle P? Well, if we add angles R plus angle Q plus angle P, we get 180. And angle R is 30 degrees, angle Q is 90 degrees, and angle P we don't know yet. Okay, so 90 plus 30 is 120. Subtract 120 from both sides, and we get angle P is equal to 60 degrees. Okay, so 60 degrees goes here, and we know it's more than a right triangle. It's a special right triangle, and it is a 30, 60, 90 degree triangle. 30, 60, 90 degree right triangle. Okay? So this is the special type of triangle. 30, 60, 90 triangle. Okay. And I can even say right triangle. Alright, so what is the exact length of PQ? So PQ is this side over here. So I can use, since it's a right triangle, I can use my sine, cosine, or tangent, the trigonometric functions, right? So I know sine is going to be opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I use sine of angle 30 degrees, it's equal to PQ, right, divided by 12, right? So this, if I multiply both sides by 12, I get PQ is equal to 12 times sine of 30 degrees. Alright, so sine of 30 degrees, remember, we need to know sine of 30 degrees, we need to know cosine of 30 degrees, we need to know sine of 60, and cosine of 60, and we need to know sine of 45, and cosine of 45 degrees. These are things we should memorize and keep in our heads for use, or in our pockets, okay? So, or we can remember that since it's a special right triangle, 30, 60, 90 degree triangles, if you look back near number, what number was it? 105 in chapter 1. There's a math note about our special right triangles, and we know that 30, 60, 90 degree triangles, 30, 60, 90 degree triangles have the side lengths n here, 2n here, and n squared root of 3 here, right? So if you did these problems earlier, you'll remember you derived this, and what you get then is if PR is 12, 2n is equal to 12, then divide both sides by 2, you get n is equal to 6. So this side length is 6, right? So we get PQ is equal to 6 units, right, this way. Or if we know sine of 30 degrees, if we memorize it, we know sine of 30 degrees is 1/2, okay? So 12 times 1/2 is 6, okay? And we want exact, so we cannot, we could plug in sine of 30 and get 0.5 in our calculator, and that would give us the exact number. But if it's going to be some long 0.5321, so on, we can't approximate it because we want the exact length. So our length of PQ is 6, okay? So what is the exact length of QR? So what is this side here? So again, we can use this triangle, right? And we know that if n is 6, then n times square root of 3 is just 6 square root of 3. So QR is equal to 6 square root of 3 units. Okay? Is there any other way we could do it? Yes, we could use cosine of 30 degrees is equal to adjacent, which is QR, over side 12, right? And then we just multiply by 12 on both sides. And QR is equal to 12 times cosine of 30 degrees, right? And this is one that we need to know. So we know cosine of 30 degrees is just 1/2 square root of 3. And so if we multiply this across, 12 times 1/2 is 6, so it's 6 square root of 3. And they're the same, okay? Another way we could have solved this was using the Pythagorean Theorem. If we know this side and this side, we know c squared equals a squared plus b squared, where c is the hypotenuse, 12. And these are the sides, so if we know a is 6 squared and we want to solve for b, we know 144 is equal to 36 plus b squared. Okay, subtract 36 from both sides, and we get 108. Okay, we square root both sides. We could divide 108 by 36, so let's do that in our calculators just so we know. 108 divided by 36, we get 3. So this is going to be square root of 36 times 3 equals to b, because square root of b squared is just b. And 6 times 6 is in there, so we could bring it on the outside. And so this is another way we get 6 square root of 3 as length QR. Okay? So part D. Part D asks us to write and simplify the sine ratio for angle P. So looking at angle P, right, what is the sine ratio? Well, we know it's going to be opposite over hypotenuse. Because sine, we know from SOHCAHTOA, we know sine of angle P is equal to opposite over hypotenuse. And that's equal to, again, 6 square root of 3 is the opposite side from angle P, and the hypotenuse is 12. So it's equal to 6 square root of 3 over 12. And it wants us to leave this answer in simplified radical form. So this is just 6 over 12 is like 1 over 2, because they can both be divided by 6. So in simplified radical form, it's just square root of 3 over 2. So sine of angle P is equal to square root of 3 over 2. Okay? So this ends CPM Precalculus Chapter 1, number 153.